Okay, let's have a look at completing the square. I've got two expressions here. First one, x squared plus 6x plus 4. And we want to factorise this by using this completing the square method. Okay, so what we do is we start off by changing the first three terms so that we've got a perfect square. So we've got x squared plus 6x, we keep the first two terms the same. And then the third term, we actually half the coefficient in front of the x term, so the 6 becomes a 3. And then if we square 3, 3 squared is 9, and we use that. So these three terms here, x squared plus 6x plus 9, will factorise to a perfect square. Now the problem is that with the original expression, it was x squared plus 6x plus 4. Now we've got this plus 9 here. So we need to subtract 5 from this expression, just so that the 9 take 5 equals 4, and we do have the same expression. Let's just put an equal sign there. So next step, we can say the x squared plus 6x plus 9 becomes x plus 3 all squared. So where did I get that from? You half the 6 here, which is 3. Also, the square root of 9 is 3, and the square root of x is, square root of x squared is x. So we get our x plus 3 all squared, and then take 5, and that's our answer. Okay, let's look at the second one here. We've got p squared take 8p plus 23. We're going to use a similar method. Start off by saying that our expression is p squared. Keep the first two terms the same. And then to get our third term, we take our coefficient of negative 8, divide it by 2 to give negative 4, and square that. Now remembering that negative 4, I'll just put it down here, negative 4 squared is actually positive 16. So we put a plus 16 there. And then, of course, we actually need the expression to be plus 23. We've made it into plus 16, so we need to add another 7 onto that. Okay, next step, we can now write our first three terms as a perfect square, as p take 4 all squared. Notice here that negative 4 squared will give the positive 16, and this middle term is sort of double the negative 4 here to give us negative 8p. And then put our plus 7 on the end, and there's our solution.